So this is question number 48 of GATE 2020 Metallurgical Engineering. If liquid copper is cooled to 1353 Kelvin, magnitude of driving force for liquid to transform to solid is in joule per mole. Given melting temperature and enthalpy of melting of copper are 1356 Kelvin, which is our melting point, and 13 kilojoule per mole is our enthalpy of melting. So for this problem, you can also refer NPTEL lecture on Advanced Metallurgical Thermodynamics course by Professor B.S. Murthy from IIT Madras. So now let's first understand some basic concepts of driving force, that is free energy change. So for a given temperature T, the free energy change is given by delta G is equal to delta H minus T delta F, right? So if you try to calculate the free energy at melting point for a liquid to solid or solid to liquid transformation, so at Tm, which is our melting point, the value of delta G will be equals to 0, because both liquid and solid are in equilibrium and they possess equal free energy, so delta G value will be 0. So if we put this value in the first equation, let's say it is equation 1, we will get delta S equals to delta H m, which is enthalpy of melting, upon T is equal to Tm, which is melting point. So you can write it like delta Sm is equal to delta Hm upon Tm. So this will be entropy change at melting point, right? So this you can name it as a equation 2. So there is a scientist named Turnbull, which made an approximation with the assumption like Cp of liquid is equal to Cp of solid, so that the value of delta Cp equals to 0. So with this assumption, Turnbull gave an approximation named as Turnbull's approximation. So what he did is he put the value of delta S in the equation 1 with the assumption of this, that delta Cp equals to 0. So we get a relation which says delta G value, which is nothing but driving force, will be equal to delta Hm dot delta T, which is degree of undercooling, upon melting point. So this relation is known as Turnbull approximation, which will give you the value of driving force for this liquid to solid transformation with a given undercooling, right? So with this relation we will solve this problem. So we have to calculate the value of delta G. So delta G will be equal to delta Hm, which is enthalpy of melting, and the value of enthalpy of melting is given as 13 kilojoule per mole. So 13 into 10 to the power 3 joule per mole into delta T. Delta T is our this undercooling. So we are giving undercooling of 1356 minus 1353 Kelvin. So this is the value of delta T upon melting point. Melting point of copper is given as 1356 Kelvin. So if you simplify it, 13,000 times 3 upon 1356. So finally you will get the value of delta G equals to 28.76 joule per mole. So this will be the value of driving force for this transformation. So the right answer is 28.76. Thank you.